Okay, let's move on to the next part, which is our trigonometric basic facts. Now look, I think what I've been trying to get you to do is to interpret and use your exact values trig, your white sheet, much more deeply than students have been. And the reason for that is because when we get to this trigonometry section, there's some things in here that need to be emphasised and there's some things that don't. And so getting that wisdom and getting that into you is very, very difficult, okay? But over a long period of time, I found it to be true. So what I want to do is, look, there's Pythagoras. We've done that. We've done that with the development of our sheet, okay? So how are you going with your development of your sheet, okay? We did it with the river, remember? And we had our square. And we had 1 and an unknown. And the siblings was over here. And the siblings was the sum, wasn't it? We add those together and it's equal to this one, okay? And we did 1 squared plus x squared is equal to whatever it was, 2 squared. So x squared would be equal to 2 squared minus 1 squared. X would be equal to the square root of 4 minus 1, which is the square root of 3. So we've been doing it. So if you haven't been paying attention, when we look at this, it's going to be like, where have I seen that before? So we've always been able to do that, and I've ad nauseum helped you generate a version of this, which has been in terms of y and x, and 1, and so using the associations and getting you to think in terms of the associations. So that's been a very important part. All right, for each of the right angle triangles below, honestly, you know, it's Sokotoa. This is not going to cut it. Okay, this is not going to cut it. This is all we're doing here. So, you know, sine is opposite over hypotenuse. So we're going to get y over z. Cos is x over z. Tan is x, rise over run. We know this, okay? Same kind of thing, looking at it from this angle. 3, 4, 5 is a carpenter's triangle. That's how carpenters do it. They don't have to do the computations. But again, sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. Okay, so these are just de-emphasised for me. They're important. I'm sorry, but it's just the way I feel. So that's your hypotenuse. So sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. Now, just doing these, and I think I picked these up for you as well with Wrk1, because some of you have forgotten or didn't bother with it. So we can put in 7 times cos 49, and it'll give us a particular answer that is of interest to us. But of course that's a very difficult set to do. But what we can do is ask it to round to dp. Okay, and so you've got to get some experience one way or another in generating your answers. Okay, so if we do just go back from that one, 4.59 to the 2, it would be 4.59. That's rounding. Okay, it's not significant figures. Okay, so it's 4.59. Now when we do a few of these, they'll come out. So using your calculator, cos 49, using cos, making sure that you're in degrees here, times 7, 4.5924, okay, 4.5924, so the 2 stays down and you become 4.59. Alright, so there's quite a few of those that we can be doing. Okay, alright, so 4.5, so that was that one. Okay, same again, 52.4 sine theta, so we'll bring this over, 27 degrees, so we're doing sine multiplied by 52.4, and so 52.4 is 23,789. Now we could argue that the 7 goes up, but you know what? It says 2 decimal places. So you've got to do what it says. So the 9 will take the, is greater than 5, so it will take the 8 up to 9, but you stop there. So it's 23.79. So you've got to get used to that. You've got to get used to the whole halting, okay, and accepting, as it were, accepting what you're doing, okay. So 20.7, take the trigonometry, what are we taking here, tan, so the tan of that, and multiply that by 80, and so we get 3.229. Now the 9 will take the 2 up, but then you have to stop, so it'll become 23, 30.23. Okay, 30.23. So that's all you're doing. Just going through and making sure that you understand that. Okay, so 47 sine divided by 18 is 0.0406. Now, 2 decimal places, so it's going to be 0.04. Okay, you've got your technology to help you. So if you're in doubt, ask. It's as simple as that. Okay, sine 47 divided by 18. Just check what you're looking at. Make sure that it processes it the way that you want it to do. And that's exactly what we said, 0.04. Okay, 0.04. 2 decimal places. Okay, cos 50.4. 50.4. Take the cos of that and divide by 21.9. So 0.029. Well, there's only one answer for 2 decimal places, and that's 0.03. It's got to be equal to 0.03. Okay, you can check it anytime you're doubtful. You can check. Okay, so please do that. Cos 50.4. And then, what are we over? 21.9. Okay, you can check them and do it by hand. Okay? So, you just got to check them. Cos 50.4. Now take the 2dp off. So there's our 0.045. Okay, 29. 0.045. So 5 and up. 5 and up makes that 0.05. What did I put that for? What did you put it for? You do something wrong here, cos 50.4 divided by 21.9 in degrees. 0.4. Okay. Alright, 28.2, let's put the tan 62 in. 28.2, let's put the tan 62 into the bottom, so 62.3. Take the tan of that, put that in the memory. Okay, and 28.2 equals 1. There you go, 14.805. Now, 2 decimal places, so I want to try Wolfram on that. 28.2 over tan 62.3. So tan 62.3 and 28.2 on the top. Okay, so that's why I'm getting the difference. That's better. Because Wolfie was in radians, not degrees. Okay, so 14.805. Let's have a look at 2 decimal places, please. Well, we know what it is, but humorous, okay? Because you want to check, don't you? And try it in degrees again, please. That's why the other one was different. So 14.81. It's 14.8, the 5, so it makes it 14.81. Okay, 14.81. Okay. So that was good. I'm glad Wolfie was in the wrong thing because it gave us the wrong answer, which is great. Now, I'm just going to put that 50 back in. Cos 50.4. That was 21.9. 2 decimal places, 105. Use degrees instead. 3, which is what we got on ours. So we're happy days. Okay, so you've got to really make sure that your calculator's in the right one. I mean, I did it with Wolfram. How hilarious is that? So tan 57 and sine 21. Tan 57 and sine 21. So we've got tan 57 and we've got sine 21. Now I'm just leaving spaces, but you'll need to be careful with it because if you let things sit up, you'll be taking the sign of the wrong thing. So let's see what happens. Okay, degrees instead, please. That's better. Using degrees, 4.21. Okay, let's just take the decimal points off. See what happens there. And in degrees, so you've got to continually tell Wolfie to use degrees. 4.212. So 2 decimal places is going to be 4.21. So we can put this back on. And I'll need to reset it because it'll tell me in radians. So that's unfortunate. And in degrees, please. 4.21. Okay, so you can do it. It's just a matter of making sure that you're. I'm glad I did that. I'm very glad. I'm going to force that next time. Make mistakes just for the fun of it. Okay, so there we have it. We've got all of our things there. 2 decimal places. Find x. So what have we got? Cos 50 is equal to adjacent over hypotenuse. So we're multiplying through by 32. So we get 32 cos 50 is equal to x. So x equals 32 cos 50 is 20.57. Very good. Sine. Oh no, it's no hypotenuse, so it's tan. Toa. That was K. So tan theta is equal to adjacent over opposite over adjacent. So it's x over 16.2. So therefore theta or x is equal to x is equal to 115.27. Okay, looking from this way, it's opposite over hypotenuse, so it's sine. Okay, so sine 33.4 is equal to x over 48.4. So therefore x is equal to 26. Very good. So making sure your calculator is correct. Okay, very good. Alright, getting to know your calculator. So in this case here we're at 1 decimal place. We're still in degrees. And we've got the problem of finding the unknown. So immediately what screams out? What screams out is undo. So the sign of is undone by arc sign or inverse sign. What you do to one side, you do to the other. Very good. So that's undo. So therefore, theta is equal to 66.2 degrees. Okay, with this one here, cos theta is equal to 0.6432. How do we undo cos? Arc cos or cos inverse. And what you do to one side, you do to the other. Okay, and you plug your calculator in, that's undo, so it's gone. And cos to the minus 1, 0.6432 is 49.97, but it's only 1 decimal place, so it's going to be 50 degrees. Tan, how do we undo tan? Arc tan, or tan to the minus 1. What you do to one side, you do to the other. Undo. Easy peasy. So theta is equal to 1 decimal point, 60.2 degrees. Okay, so these are just something you need to practice. Alright, what I'm going to do is press that one there, pause, and come back to it for the video. Thank you.